We can use ASAP to analyze virtually any optical system independent of wavelength. Within ASAP, you'll simply define the wavelength of interest as well as the optical materials and the index properties of those materials. So in this particular case, what I have is a system that's designed to operate at 0.6328 microns, Heine wavelength, and the component is made of the shot material BK7. And in this particular case, what we're going to do is optimize this lens. Initially, we're starting with a lens that has a shape factor of 0, so a symmetric lens, and we'll let ASAP optimize this to determine what shape factor would give the best performance. So let me run this lens, or this file. And as we can see, we started initially with a symmetric lens with very poor image quality. And we can see that by optimization, ASAP can minimize those aberrations. And by looking at my command output window, I can see that this is the idealized lens after the optimization. So it is no longer a symmetric lens. The front radius and the rear radius are provided here. So if I wanted to order this lens from a lens manufacturer, I have all of the specifications that I need. Similarly, I could go to this lens and let's say I want to do the same thing, but I'm interested in 10.6 microns. So let me simply modify the file, and I'm going to change my wavelength to 10.6 microns, which is of course a CO2 laser. And I know within my glass catalog over here, I have the information about the material germanium, and that's stored in the ASAP unusual catalog. And the material is the name of the catalog plus the name of the material. So again, what we're going to do is start again with a symmetric lens and let ASAP optimize to give us the best performance for a germanium lens at 10.6 microns. So again, let's run the file. And we can see that the performance is a bit different at the germanium wavelength. And we can go back up here and scroll. We see that we have a different set of radius values to be optimized for 10.6 microns using germanium. We could perform the same analysis with an ultraviolet material, simply have a material in the catalog or provide the index information to ASAP and do any optimization or analysis, just as we did for visible and infrared.